Hello friends, in this problem a semicircle inside a quarter circle is given. So this is the semicircle and this semicircle is inside this quarter circle. Length OS is given which is equals to 3 unit. So this length is 3 unit. Basically this semicircle is touching this radius OB at point S. This means OB is a tangent to this semicircle. And it is also given that arc length OAQ, that is this length, is equals to arc length BQ, that is this length. Then we have to find the radius of the semicircle. So CQ is the radius, CP is also a radius, let's call this R. Then we have to find the value of this R, that is radius of semicircle. How will you solve this problem? I will solve this problem by using some constructions and I will use Pythagoras theorem. So let us try to see how we can solve. Let us first connect point C with point S. So this is the radius and this is tangent, and radius and tangent are always perpendicular. So this means this angle is 90 degree. So I can say line CS is perpendicular on line OB. Also CP is the radius, CQ is the radius and CS is the radius. All are equal to R. So CP is equals to CQ is equals to CS and all this is equals to the radius R. Now let us draw a perpendicular from point Q on line OB. So this QT is perpendicular on line OB. Now see, what is this angle? That is POS. This angle will be 90 degree because this is a quarter circle. So this angle is 90 degree. This angle is 90, this angle is 90 and this angle is 90. This means PO is perpendicular on OB. That is OP or PO both are same. OP is perpendicular on OB and SC is also perpendicular on OB. So this is here, and QT is also perpendicular on OB. So these three lines are perpendicular on OB. This means these three lines are parallel. So now I can say OP is parallel to CS and this is parallel to QT. So these three lines are parallel. Now I will use a theorem. And this theorem says if we have various parallel lines and two lines are intersecting to these parallel lines, for example in this case this is one line that is intersecting these three parallel lines and this is another line that is intersecting these parallel lines. So in this case ratio of segments are equal. This means PC divided by CQ, this is equals to OS divided by ST. So now I can say PC divided by CQ is equals to OS divided by ST. Now PC is R and CQ is R. So this is R by R. This means 1. So this means OS by ST is equals to 1. This means OS is equals to ST. So this both are radius. So this means OS is equals to ST. Now OS is given, that is 3 unit. This means ST is known, that is this is also 3 unit. So OS and ST both are equal and this is 3 unit. Now in the problem it is also given that arc length AQ is equals to arc length BQ. So this length is equal to this length. So now I am going to use this given fact. So to use this, first let us draw a perpendicular CM. So from point C, I will draw a perpendicular on QT. So this is the perpendicular. So CM is perpendicular on QT. And connect OQ. I will connect O and Q. Now let us consider angle AOQ and also consider angle BOQ. Now if you remember, this arc length and this arc length are equal, then there is a theorem that says equal arc lengths subtend equal angle on the center. So this arc length subtends this angle and this arc length subtends this angle. So this means this angle and this angle are equal. But this total is 90 because this is a quarter circle. This means this is 45 and this is 45. So these two angles are equal, that is AOQ is equals to BOQ, and both are equal to 45 degree. So this angle is 45 degree and this angle is 45 degree. Now let us consider triangle OQT. So this is O, this is Q and this is T. So this triangle. Now in this triangle I can write tan 45. So tan theta is equals to opposite, that is QT, divided by adjacent, that is OS. So this is QT by OT and this is equals to tan 45 degree. And tan 45 is how much? Tan 45 is equals to 1. This means QT by OT is equals to 1. This means QT is equals to OT or OT is equals to QT. So this case I can say OT is equals to QT. So this length is OT and this length is QT. So these two lengths are equal. Basically this was 3 and this was 3. So this total is 6. So this is also 6. Now let us consider this triangle. Basically rectangle in this case. CMTS. This will be rectangle. You can prove this. This angle is 90. This angle is 90 because this line is perpendicular on this. And this is also 90 because we have drawn CM as perpendicular on QT. So the rest angle will be 90 degrees. So all these four angles are 90. This means this is a rectangle. And we know that this length is equals to this length and these both are equals to 3 unit. So we can say length CM is equals to 3 unit. Because this is a rectangle. So this CM will be equal to ST and ST is 3 unit. So CM is equals to 3 unit. So CM is 3 unit. And CS, that is this length, will be equal to this length, MT. But this is the radius. This means MT is equals to radius. MT is equals to R. Now what is QT? QT, as I said, QT is equals to OT and OT is 3 plus 3, that is 6 unit. So QT is equals to 6 unit. So that is QT is equals to, we can also write QT is equals to QM plus MT and this is equals to 6. So I can rewrite QT. QT is basically QM plus MT and MT is known. MT is nothing but radius. This is here. So now I can write QM is equals to 6 minus MT and MT is the radius. So this is 6 minus R. Now let us consider triangle CQM, that is CQM, this triangle. This is radius and we know this is 3 unit because this is a rectangle. So this is 3, so this is 3 and this QM we already calculated, that is 6 minus R. And this is a right angle triangle. So I can again use the Pythagoras theorem. So I can write, in this case, this is the hypotenuse, CQ square, this is equals to CM square plus QM square. So this is here, CQ square equals to CM square plus QM square. Now CQ is the radius, so R square, CM, this is 3 unit, 3 square and this is 6 minus R. So 6 minus r whole square. Now let us take this to the left hand side. So this is r square and this will become minus of 6 minus r square. 6 minus r whole square. And this is equals to 3 square, which is equals to 9. Now this is written a square minus b square. A square minus b square is equals to a minus b into a plus b. So this is a minus b. So minus 6 and minus minus plus, and then a plus b, that is r plus 6 minus r. So in this case r cancels. So we will have here 2r minus 6 and here I will have 6 and this is equals to 9. So 2r minus 6 is equals to 9 by 6, that is 3 by 2. So from here I will get r equals to 15 by 4. So in this case radius of semicircle, that is this length, is equals to 15 by 4 unit. So I hope you enjoyed this problem, and if you like these problems, please share with your friends, like this video and subscribe to my channel. I will see you in the next video. Thank you.